Okay, we are getting down to the last few lessons, and we are starting lesson 8.8, differences of squares. Do you remember when we were multiplying polynomials? If they were the same numbers, 1 plus, 1 minus, then the answer was the square of the first minus the square of the second. Same numbers, plus, minus, square of the first minus square of the second. Same numbers, this case they're letters, square of the first minus square of the second. So here, when we're given perfect squares with subtraction in the middle, then we're going to go opposite. So it's going to be this, x minus 6, x plus 6. Take the square root of both of them, 1 plus, 1 minus. So this becomes this. Here's another example. M squared minus 64, so it's m plus 8, m minus 8. Take the square, 1 minus 1 plus. So here, 64y squared would become 8y minus 9z, 8y plus 9z. This one's a little different because we have something in common that we have to factor out first, and that is 3b. So it's 3b times b squared minus 9. Now we have difference of perfect squares. So we still have to have 3b in there, but then we're also going to have b minus 3, b plus 3. So watch for that. If they have something in common to begin with, you need to factor that out first. Okay, so now here we're going to have some different types as well. Taking the square of the first, that's y squared. The square of 625 is 25. And then y squared plus 25. We're not done because this is the difference of perfect squares. So we have to do it again. Y minus 5, y plus 5, and then also include these, but we can't separate that because it's not a minus. So this is the final answer, y minus 5, y plus 5 times y squared plus 25. When you do that, you come up with another perfect square, difference of perfect squares, you have to do it again. You cannot do it if it's a plus, it can only be if it's a minus. Okay, so here, this is 16 minus n squared, and 16 plus n squared. So again, we have a perfect square here. So it's going to be 4 minus n, 4 plus n. This one's a plus, so it's going to stay the same. So final answer right here. Here we have something we need to factor out first, and it's 9x. So we're left with x to the 4th minus 6. So this becomes 9x times x squared minus, oh wait a minute, no, we're done. 4, shoot. Okay, I'm sorry, so this should have been a 4, not a 6. So now we have a perfect square, x squared minus 2 and x squared plus 2. We're done, these are not perfect squares, so that's the final answer. Okay, this long one, we need to take out what it has in common first. It has a 6 in common. So we're left with x squared plus 5x minus 4. I'm sorry, just 5. Yeah, 5x minus 4x. That should be x squared, that should be x cubed, minus 20. And we can split these up like we do when we're factoring ones that we've done. So I'm going to split these up into x cubed plus 5x squared and negative 4x minus 20. I can pull out an x squared here, and I'm left with x plus 5. I can pull out a negative 4 here, and I'm left with x plus 5. So the final answer is 6 the middle ones that are alike, x plus 5, and then the outer ones, x squared minus 4. Now we're not done because this is perfect squares. So actually, we're going to make that x minus 2x plus 2, and we have to include, I'm just going to erase that, we have to include the 6 and the x plus 5. So the final answer is right here. A lot of steps on that one, so you have to watch that. Here's a different type. We have y equals q squared minus 4 over 25. When y is 0, what is q? So basically we're solving like we did when we had an equal sign when we were factoring trinomials. So if we make this 0, we're just going to do like we were doing before. This is perfect square. If it's a fraction, that's perfect square, that's perfect square. So we're just do top and bottom. So 0 equals q minus 2 fifths and q plus 2 fifths. Setting those both equal to 0, to positive 2 fifths and negative 2 fifths. So if it is a fraction, perfect square, just do top and bottom.